So, um, so I made a flower recognition app, but more than a flower recognition app, it's a format that anybody can use. Even if you don't know anything about machine learning or Python, you can still use this app. Not an app, it's a code. You can use this code in order to create uh, image recognition. Um, Anything image recognition app, image recognition um, website, anything, you can create it using this code. It's very simple yet powerful, and you can make something like a app that recognizes if something is a dog or a cat, app that recognizes if something is a someone is a guy or a man or a woman. It can recognize it. So what you need to do is you can click the link above and it will redirect you to this page. What you need to do after that is you need to click the edit button. After you click the edit button, it will redirect you to this page. This page is where the magic happens. Let's see. Now I'll go briefly through all of this so that you get the general idea of how this code works, and you can change it, tweak it a very little so that you can make the thing that you want. So you can see I'm using a flower recognition dataset from Kaggle. What I'm doing first is I'm importing all the required libraries. Then I'm making a mm, training and validation dataset. Here I'm making batch size 32. It's a standard batch size. After that, I'm using data directory as this. Uh, what You should really change this if you want to use it with other. If you want to make your own model, like I have a flower recognition dataset inserted here, and I copied it. And after I copied it, I inserted the link here. If you want to create a new make find if you have a new data set, you can get the new data set in Kaggle. Whatever data set you want, dog and cat, man and woman, you can get it in Kaggle or from anywhere. You can insert it using this button upload data, and you can enter the data name, you can browse the data, and you can enter it, and after that you can copy the link and paste it here, and it should work just fine. After that, I am separating it into test, train, and validation dataset. After that, we can see I just I'm just printing out some of the images that are in our dataset randomly. After that, I'm printing out the batch size, the image size, etc. Yes, now we are using data augmentation. Here in data augmentation, we are flipping it, rotating it, zooming it, because the more the data we have, the better the model will perform. So I am doing all this thing, and I am also plotting some of the things. Like this is probably Daisy, I guess, and we are rotating it, we are changing its contrast, everything, using data augmentation in order to train it more efficiently. And we are printing all the class names. This is a necessary part of the code, because maybe you have a boy and a girl here, or what, dog and a cat here. So basically, Daisy means the value of Daisy is 0, dandelion is 1, rose is 2, sunflower is 3, tulip is 4. Now we are making two models, one using global pool, one without using global pool. You don't really need to understand about global pool in order to use my format, but it's basically a type of model making. With global pool, you are more compressing the data, you are averaging all the data, while without using the global pool, you are the transitional data still remains. So it's not very necessary. Just see this. You can see we are auto tuning it. Then we are writing number of classes equals to 5. If you have only two classes like dog and cat, then you need to write 2. After that, we are using an early stopping method. We're making a model using keras, and we are having loss as a cross entropy. Um, then we are getting this. I forgot to tell at first, you need to actually click on this run all in order to get all of this. I've already clicked run all, and I got this all. uh, it might take some time for you, and this data might overwhelm you, but it's not very overwhelming, because all you need to understand is this data right here, validation accuracy. You can see that it's around 0.79. So our model is 79% accurate most of the time. All of the time it's 79% accurate. So we made another model using global pool. This model's name is called model 1. So with global pool, the validation accuracy has become 79%. So that's also very close to the first model. And I've also printed out this: daisy is 0, dandelion is 1, rose is 2, etc. So we are using this model to find individual label. All right, so what I'm doing is, I have this data, I have this code right here. Maybe you want to test out this model. So you can just take out your mobile, you can click a picture of a flower, and then you can upload this picture of flower from this, clicking this button. You can type the flower name, maybe sunflower, flower, and then you can browse the files, and you can find the image of the sunflower, and then we can open it. And after that, we can click on create. uh, it's loading. Oh, it's showing that it has duplicates, because I have already uh, mm, mm, yes, it's showing that it has duplicates because I've already downloaded sunflower, the same image here. So yes, now let's find out if the our model actually finds out if this image is a sunflower or not. So here we are importing image, then we are having path. The path must be the path of the image. So I copied it and then I pasted it here. You can do the same. And we are having a target size. The size must be 180 180. That's what our model has been trained on. Then we are converting our image into a array, and we are predicting the image, and we are printing the prediction, and it's 3. Let's see what 3 is. And 3 is sunflower. So our model, meaning the first model, got it right. Let's see if the second model gets it right. Model 1 was the name of the second model. So yes, it gets it right too. It's also 3. So so it works. Thank you for watching. I'll be making more videos about machine learning, so keep watching. Thank you. Oh, also, if you have any problem, any problem while making your own machine learning algorithm to find out, to recognize images, then you can always message me through LinkedIn.